Hello everyone, welcome to another episode of Mr. Brown's Secondary Science. Today we are going to be drawing two lines on one line graph. Now in science you may be asked to plot two objects, two items on the same line graph based on a table of data. You may think, well, how can you put two objects on the same graph? Surely you'll need them on just different graphs. Nope, if they're on the same graph, you can compare them. You can compare them both. So today we're just going to quickly go through that procedure and show you how easy it is. So first of all, you can see that I have my chart, my table full of data. We have time at the top, 0, 1, 2, 3. All the numbers we need to make a scale from it, and we have our unit as well of seconds. Underneath we can see the data for our first object that's going on this graph. This one, object A, again we have a unit, we know its distance is being covered in meters, and we have numbers for it, so 0, 1, 2, 3. The number of meters this object is covering in these numbers of seconds. There we are. And finally, object B, again we have units, we have meters, we know that object B is covering distance in meters, and we have the numbers there to go with it that correspond to the number of seconds that it's traveling. So after 6 seconds, you know object A has traveled 6 meters, but object B has traveled 10 meters. Now let's look at our graph. We have first of all a title. Every graph needs a title. This one is distance traveled versus time. We have our x-axis, we have our y-axis, we have distance on y, and we have time on x. Now these at the moment are missing their units. We need to add them in. So time we have seconds, distance we have meters. Now, we are also missing numbers from our scales. I have already drawn them with the little graduations to where our numbers need to be. These graduations, if you're going up in one each time, then the distance needs to be the same between them. So for time, we can see that we are going all the way up to the number 9. So I am going to put on time, starting at 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. And then for distance, we are going up to 10 with object B. That is the largest number we need to deal with. So I am going to do my axis here all the way up to 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. All the way there. Now I need to plot this data on this graph. Now there are a lot of numbers, but don't worry, we are going to do them one at a time, and we are going to do first of all object A. Now object A, I will swap the pencil for the pen just there, because when we do a graph you make sure it's not staying where it is, so I'm going to use a handy what can I use? I'm going to use a handy remote control just to cover the numbers for B. Now we're going to do this one at a time. We're going to plot object A first, and then we're going to plot object B. So object A. First of all, we know that at 0 seconds it's traveled 0 meters. So that is the first point on our graph. Next point, at 1, it's traveled 1 meter. So we'll plot that 1 to 1. After 2 seconds, it has traveled 2 meters. So we will continue in that vein, and we will know that this object will travel 4 on 4, 5 on 5, and that pattern will keep going in a lovely straight line. Now you can see I'm using plain paper. It is a lot easier to do this on graph paper, but as I'm doing this quite quickly now, final point 9 for 9, you can see that we now have all the points to plot our graph. As I've done this a bit roughly, not on graph paper, not all the points are going to be as exact as I would like, but that is a line of best fit with our points on our graph. Now we need to do object B, so we don't need to worry about these numbers anymore. We've plotted A. Now we are plotting B. So first of all, again, 0 to 0. The first point is 0. Next up, after 1 second travelled, this time it's travelled 2 seconds. So I'm going to use a ruler this time to help me be more precise. And we have there 2 meters travelled after 1 second. Next up, we have 4 meters travelled after 2 seconds. So I will plot that again in the same way here. This goes up to 4, and you can see there across down to 2 we have plotted to 4 meters. 2 seconds just here, 4 meters just here, and this is where our point goes. I shall continue to plot this. So 3 seconds we have 6 meters. Again, just measuring across, making sure we're as precise as we can be. At 4 we have 8, so we'll go up to 8 here, just like so. Then at 5, now it's 9 seconds at 5, so 5 seconds time, you've travelled 9 meters this time. So being very careful, 5, measuring up to the point here where we have 9, and that is our point. At 6 we now have 10, so 6 measuring up to match where 10 is here. I shall measure across again, and there we have the 10, and I can see now that for 7, 8 and 9 seconds it is 10. It stays as 10. The distance stays as 10. So for the remaining points I can put these 1, 2, 3, there we are. I can draw them in, and now I need to do my line of best fit for object B. Same again. I'm going to do a nice straight line for the first bit. At the second bit you can see the plotted points go in a different direction. So I'm going to plot a straight line there, and I'm going to plot a nice straight line for the final points here. Now I am going to label these lines. The first line, I know that is for object A, and I'm going to very clearly label that. And the next line, the second one we did, that was for object B. There we are. And I shall now double check. I have a title. I have axes with units on Y and on X. I have lines of best fit to go with my plotted points. I have done it in a pencil as well. Very important that I've used a pencil so that I can rub out any errors that I may have. So if I wanted to correct the placement of that point so it was more exact, I could do so. And I can see I've labelled the lines of best fit correctly for the objects they match. That's it, guys. We have plotted our graph. We have plotted it for the 2 objects that we have in our table, and it is done. It is finished. It looks good. Thank you very much, guys. Please subscribe to the channel if you found that useful. More videos helping you out with GCSE and KS3 Science will be uploaded. Please add a comment if there is anything you'd specifically like me to help you with. Thank you very much. That is Mr. Brown's Secondary Science.